Now I'm going to create a brand new Unity project, and in this project I'm quickly going to go over making a voxel. So I'm going to call this one voxtoot 5 and say create. I have a new scene, and I'm going to add a empty game object to represent one voxel right now. So I'll give it that name, and oops, I'll make a script. I'll call it well, I'll make a script. I'll call it Voxel. All right, and this is what's going to be inside the script. Let me open that up. Okay, here we have our default stuff for Voxel, but I'm just going to clear out and start over. Kind of make a helper section here, and in the helper section I'm going to have some enums. So I'm going to enum all the corners that we had in our voxel, the A, B, C, D on the bottom and the E, F, G, H points on the top. I'm also going to enum out the sides, and in the enum name I'm going to mention the points that make up the side and the name of the side. And what else should I do? That's all I need for my helpers to enum. I'll need 3 arrays to hold the data that I'm going to give to the mesh from my voxel object, and the 3 arrays are to hold the vertices. Those are the points in 3D space. The UVs, which are basically, it's a mapping of the point to say what part of the texture is going to draw at that point. And then the triangles. I have a bunch of points, but to make a polygon, I got to connect the triangles. And I got to connect the points into triangles, and that's what this array has. So for the vertices, I need 24. The UV, I need 1 UV per vertice. And then for the triangles, I'm connecting points to make 2 triangles per side. So I need 36 integer pointers to the vertices. I'm going to add a variable called voxel size. So each voxel, the size is actually 1 unit. And I'm calculating all my voxels, the points for all the voxels based on a center point, and from that center point I go in each direction to make the corners. So the amount that I go from that direction here is the voxel size, which is really like half the size. And this here is something that will show in the inspector so that the voxel size is a slider bar instead of just a text box to put a number. That way the user could just drag the slider bar to pick the value of the voxel size. All right, so in my voxel, I'm going to have the corners, the vertices, and to calculate each vertice, I made a function where I pass in the corner that I want, A, B, C, D, E, G, or F. And in here, the corner is an enum code for corner. Here's the letters. So I could say I want the A corner, and it'll come in here. First, it'll calculate the low and the high value. So if this is my little comment to show a representation of a voxel, point in the middle is the position of my voxel. And if I wanted point A, I'd have to go down into this corner. So which way I go from the center point, it's either I'm going to go down minus or up plus on each axis. So here's my little formula for A, it's minus, 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 which is low, low, low. And B is plus, minus, minus, which is high, low, low. And I continue, and I got all 8 possible vertices, and this returns a new vector 3 so that every time I request a point, it's actually giving me a new instance of a vector. And this is just here just in case. I have a switch statement. If by any chance I mess up somewhere in the code, this will put a little debug message on Unity to tell me I messed up, and this is where I did mess up. So this is my corner function to get a corner. And what's the next function I need? So sides of my voxel are kind of made up of a set of 4 vertices each. So over here I have a function that says get vertices for a side, and I pass it in an enum, which I tell it which side I want. And in here, then therefore, I just find out the offset into my vertices array, which is whatever the side is times 4, since there's 4 points per side. And if you want the back side, well, kind of look at that little graph over here. The back would be EFAB, and what do you know? I nicely labeled my backside EFAB for the corners I need, and here I add the corner EF, A, and B to my vertices array, and I do the same thing for the other 6 sides, except, with the corresponding points that they need, and that takes care of populating the vertices array for a side. What else is next? All right, so the next function I'm using is set UV side. For every vertice, there has to be a UV that says where from the texture do I grab the picture to map onto that vertex, to map to that vertex. So the UVs here, I take a side, so I'm going to do everything by sides for my voxel, since sometimes the side may be off or on. So over here, the UV side and the texture I want to put here, a new texture. I added another enum here, and I just added an enum to name each piece of a texture that I want to use from my texture map here. So I'm going to add this sprite to the project, and over here I have 4 by 4 images in one sprite, and I'm going to use that for my material. So what basically means is that here's 0.00 and here is 1, 1. This is 0% of position of my texture, and this is 100% of this texture. And what I do once I specify a texture with this set UV side is I take the texture they want and I calculate, since each one of these is 128 pixels, each one of these blocks, and there's 4 of them, that means that the whole thing is 512 pixels. So first I calculate the pixel locations of, say, dirt, if they wanted the dirt texture over here. So the low X and Y would be right here, and then the high X and Y would be right here, and I'd be getting the pixel positions of this and this, but UV doesn't want pixels, it wants percent. So down here, after this big select case for reading the different locations in pixels, I convert the pixels to a percent, a value from 0 to 1. And that's what this does here. And now I have the UV in percent of the low and the high, of value from 0.0 to 0.1. And I just set the UV coordinates for the corresponding index in the UV array to the proper thing. So for the back, right, forward, and left, the calculations for the sides of those coordinates is minus, plus, 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 minus, minus, plus, minus. I'm using the same idea I used when I was defining the vertices, except now instead of like moving away from the center out, I'm moving from a position in this to the bottom coordinates and the top coordinates, blah, blah, blah. All right. And then up, the actual values are different. For the top side, it's minus, minus, plus, minus, minus, plus, plus, plus. See, it's different. Excuse me. And then for down, it's this. So that gives the UV per side based on the texture. So the big thing here is the texture to see where in the texture map am I going to grab the thing from. So let me just add that texture to my project there. All right, good. And I'll make a material out of it when I get back. All right, so that is another function. I have the ability to set the vertices for a side and the UVs for a side. So what's next? Set triangle side. This is going to take a side from the enum side and whether you're going to turn that side on or off. So on equals 1, and there by default you're going to be a value of 1 if you don't provide a value. So here, for every side there's 6 points to a there's 6 points to a triangle for every side. So whatever the side is, you multiply by 6 to get to the offset in the triangle array that you want to set the values for. Now here I just do a little bit of shorthand coding in C#. So for the E point, say if you're trying to get the back side, EFAB. So E is equal to 0, F is 1, that's the index into the vertices array. E is 0 for the backside, F, A, and B. But if on is not equal to 1, then we'll just set it to 0, which means triangle points are basically 0, and it's not going to draw a triangle on that side. So the way you read this notation here with the question mark is E equals, then it does a little condition test here. It sees if this thing is true on the inside. If it's true, the question mark will use the first value here, and if it's false, the question mark will use the second value. So that's how you read this kind of shorthand, the C# shorthand. And then the triangles are basically made of 3 points each. EAF, BAF, all right, and the order that you connect the points in has to be clockwise to the direction that you want to see the points. So clockwise connect determines which side will render. So if you happen to go through here and I did FEA, my point of view to the camera, it's not going to be visible. Anyway, so the order matters that you connect the triangle, the 3 points, okay? Because that determines which side of the triangle gets rendered. Unity is not going to render both sides of the polygon of the face. So I got that for back, right, forward, left, up, and down, the 6 sides. All right, that's to set triangles. What else do I need? Now I probably need something to actually set all this data and then take the data and set it to the mesh. So private void start. This class is going to be attached to my game object over here, the voxel one, which currently right now it just has this. So I want to be able to drag the script and put it on here. And then I want the game object to have all the components that it needs. So I'm going to, at the top here, just add 3 required components. And the 3 components are a mesh filter for the mesh, a mesh renderer, so we could map the materials onto the mesh, and then a mesh collider so we could detect collisions on this mesh that we're creating in the script. All right, so back to the start function. First thing we're going to need to do is get a pointer to the mesh. So to get a pointer to the mesh, remember this. When we add the script, it's not going to have any mesh set to it, So the first thing we have to do here is actually instantiate a new mesh object. Then we could, for this game object, get the mesh filter component and set its mesh equal to our new mesh object. And then we'll also set that mesh that we just instantiated to the mesh collider. All right, those 2 things actually need our reference to our mesh. Then after that, we actually just have to create the data for our voxel. I call the set vertices for the 6 sides. And then I call the set UV for the 6 sides. And here I'm going to set the sides that are like the front, back, left, and right to be grass dirt. And grass dirt is this picture right here, where the top is grass and the bottom is dirt. And then on the top, I'm just going to have grass. And then on the bottom, I'm going to have dirt. So you'll see what that looks like. But I could say which texture I want on each side. And then, of course, I have to make the triangles out of the vertices. So I call the set triangle function. So now you can see like why I made these functions. It makes it kind of easier for me to build the voxel and know what I want to do with it. Ooh, now I wonder if I'm ready to, the script is ready. I think it has everything it needs in it. Let me just truncate it down here, collapse the definitions just so I could see. Yep, I have my enums. Then I have my voxel size. Then I have the data that I'll feed to the mesh, vertices, UV, and triangles. I put this private here for these integers so that I don't have to declare them every time set triangle side is called, and then here's a pointer to my mesh. Okay, it looks like the script is ready, so I'm going to save it, and let me look back to Unity, and here in Unity I have the script. So let's put the script onto the voxel game object, the empty voxel game object. So I'm going to drag and drop, and it did work as expected for the require components. As you can see, when I drag and drop the script, I have the mesh filter that got added, a mesh renderer that got added, and a mesh collider. All right, so that's good. I have these three things that got added from the three require component statements in my script that were right here. The mesh right now is none, but that's going to get set when my script runs. And the mesh renderer here, it needs a material. Let's give it a material. I want to make a material using the terrain map. So first here, I'll just say create material. And I'll just call it terrain map. And then I'll just use the terrain map as the material here when it's selected, and drag and drop that on the albedo. And here you can see the materials there. And I could view it even as a cube shape so I can see what it looks like. All right. I got things set up. Let's press play and see how it goes for the first time to make this single voxel. Will it crash? Will it work? And something is not happening. It's not working. Let's see what's going on. Let me press, let's put a breakpoint here in the start and just attach the script to Unity and then go back to Unity and run Unity. And let's kind of see what's going on. I think now I know what's going on. Here we get a pointer to a mesh. We create a new mesh. That's good. And then we set that new mesh for the mesh filter. So if you look right here, the mesh filter right now is none. But then when I step over this, the mesh filter, I guess I have to like come back to the Unity side to see it. But now the mesh is not none. This is null. Now it's not null. I go through and I make all these, all this data in my script, but I never set it to the actual mesh. That's why we don't see anything yet. So there's a little bit more code I forgot. We're going to have to actually set all this data that we defined and give it to the mesh. So here is giving data to the mesh, vertices, UV, and triangles from my scripts, vertices, UV, and triangles that got defined with all this stuff up here. And now let's see what happens. Let's run this. And something should happen. Nothing. All right, so once I get the data to the mesh, let me say mesh dot recalculate the normals. So for every polygon that's made, it's going to calculate the normal on each polygon so the lighting can work. And we have a collider. So mesh recalculate bounds so we know the size of this mesh that we made. So Unity provides these recalculates for us. I'm just using those. Okay. Will it work now? The script, I save it and I come over here, the voxel. Oh, I made this material, but I never assigned it to the renderer. Okay. Let's see what happens. And there we go. We got our little chunk. We got our little single voxel. And you could see here, since I have shading the wireframe, you could see the triangles that make up each side. And the bottom's dirt, the top is grass. Okay, good. So one chunk. Wow. We have a game with just one little voxel. That's not going to be enough. We have to make many voxels. So let's, in the next video, take this and make a chunk of voxels like 10 by 10 by 10. All right?